Hello people, so right now let's go to our lesson 2, which is all about finding the general rule or nth term of a sequence. So we have here our lesson learning outcomes. In this lesson, you will be able to find the general rule or nth term of a sequence by inspection, find the general rule or nth term of a sequence which is linear in nature, and the last one, determine the general term of a sequence which is quadratic in nature. So let's delving into finding the terms of a sequence. So were you able to predict the pattern easily given some of its terms? If not, don't worry because you are about to learn how to find general rule or nth term of a sequence given the terms of the sequence. There are actually two ways in finding the general rule of a sequence. One of these is by inspection, just like what we did with the sequence 1, 8, 27, 64. However, there are cases when we cannot do it by inspection, but can be solved using algebraic methods. So we have here example number 1. Finding the general rule or nth term of sequence 1, 4, 9, 16, and 25. So we have here our solution. Observe that 1, 4, 9, 16, and 25 are consecutive squares of integers. Right? So that's squares of integers because when we multiply 1 times 1, that's 1. 2 times 2, that's 4. 3 times 3, 9. Or 3 to the power of 2 is 9. 4 to the power of 2 is 16. And 5 to the power of 2, that's 25. That is why we can say that this is squares of integers. So we have there the n, no? So natay 1, 2, 3, 4, and 5, the number of terms. And the a sub n is 1, 4, 9, 16, and 25. So for the first term, we have 1. The second term is 4. The third term is 9. Fourth term is 16. And the fifth term is 25. Note that when the integers n are squared, the result is the sequence 1, 4, 9, 16, 25. Hence, the general rule of the given sequence is a sub n equals n squared. So that when we have there, we will be looking for the a sub 1 or the first term. Ato siya is substitute, no? So 1 squared, that's 1. 2 squared, that's 4. 3 squared. For the third term, so we have n is equal to 3. So ato is substitute si 3 sa n, that's 3 squared, 9. 4 squared, 16. And for the fifth term, that's 5 squared, that's 25. Now we have example number 2. What is the nth term of the sequence 2, 3, 4, 5? So we have here our solution. We are given with the first 4 terms of the sequence. So we have here the first 4 terms. Our first term is 2, second term is 3, third term is 4, and the fifth term is 5. That is, okay, we have to study the illustration below. So we have here, opatra ka terms ang naa. And for the first term, we have 2. Ang second term nato is 3. Third term nato is 4. And fourth term nato is 5. Note that when the integers n are added by 1, the result is the sequence. Sakto? Kung ang ato kini mga integers, ada na to siya ng 1, the result is this one. So, nata diri no 1, kung ada na to siya ng 1, the result is 2. 2, ang ada na to siya ng 1, 3. So, 3 plus 1, 4, 4 plus 1, 5. So, that means, Cn, no? Ang ato general rule of the given sequence is a sub n equals n plus 1. So that, if we will substitute our number of terms, mo equal siya sa a sub n here. Okay, so our general rule of the given sequence is a sub n equals n plus 1. Now let's go to example number 3. Find the general rule that describes the sequence negative 2, 0, 2, and 4. So we have here our solution. Observe that the general rule of the given sequence cannot be easily determined by inspection. Hence, we will solve this algebraically. So we have here the first step or step 1. Make a table showing the value of n and a sub n. So we have here, we have our first term or the term na to is 1, then the that's negative 2. Second term na to is 0, third term is 2, and fourth term is 4. And for the proceeding, we have n term is equal to question mark because we still don't know. Now, for our step 2, find the difference between each term of the sequence. So that is, so ato siya minus no, ang mga consecutive terms. So negative 2 minus 0, that's negative 2. 0 minus 2, that's negative 2. And 2 minus 4, that's negative 2. And negative, manay no? So, kini siya, kuha na to ang ila difference. So, na siya same na negative 2. Step 3, since the differences are equal, so we call that common difference, right? And the constant, which is negative 2, or they have a common difference negative 2, it means that the general rule of the sequence is linear in nature. Hence, we can use the linear equation given by a sub n equals an plus b. To solve for the general rule, to do this, we have to solve for the values of a and b. Thus, we need two equations to begin with. Note that in the table, when n is equal to 1, a sub n is equal to negative 2. Substituting these values to a sub n equals an plus b, we get a sub n equals an plus b. So, si a sub n, alista na to siya ng negative 2, di ba? And then si a, no, we have there, a sub n again. So, ang n na to, alista na to siya ng 1. Plus b. So, unsa galing ang ato kinahanglan makuha ini? Kinahanglan makuha ta ng other na equations. So, this is our equation 1, ning negative 2 is equal to a plus b. Also, when n is equal to 2, a sub n is equal to 0. Sa dire, oh. Kasi makalimutan, dire. No, ato siya pang substitute. So, substituting these values to a sub n equals an plus b. So, we get, no, this is, si an nato is 0. So, ato alistan dire si 0. And then, copy si a, ang ato n is 2 plus b. So, we have here our second equation. That is 0 is equal to 2a plus b. Okay, next we have here the step 4. Since we actually now have two equations, no? Using equations 1 and 2, we will solve for the values of a and b by elimination or substitution method. So, we have here our first equation, negative 2, is equal to a plus b. For our second equation, 0 is equal to 2a plus b. Equations 1 and 2 can also be written as a plus b is equal to negative 2. So, gibalira na nato siya. Dili na nato ikalibog. 2a plus b is equal to 0 for equation 2. Again, gipangbalira na nato siya. Now, by elimination method, we will eliminate b to solve for a. That is, again, kung kita eliminate b, kuhaon nato si b para ma-solve nato si a. Again, i-eliminate nato si b para ma-solve nato si a. So, saan man na, we have here 2a plus b equals 0. Diri no? Diri. Mao na siya gikuha. Minus a plus b equals negative 2. Kini. So, that means ato gi-minus si equation 2 sa equation 1. And then, pag minus nato, 2a minus a, that's a. b minus b, that's 0. 0 minus 2, that is 2. And then, that is a. I think this is negative 2. No, a is equal to 2 or a is equal to 2. Okay, 0. Ay, hindi pala. No. Dili ay. That's positive 2 di ay. Kaya when we subtract, di ba, is ma-change diri, mahimuning plus, and then ma-minus si a, and then ma-minus 3 si b, and then ma-plus ni. So, that's the case pala. So, we have here, this is positive. A is equal to 2 or positive 2. Since we already have the value of a, we can now solve for the value of b by substituting a is equal to 2 to equation 1 or 2. So, mamili rata kung asa ang masadyon na equation. Ang ato alistan si a. Okay, so I think mas sa dyan ang equation 1. So equation 1 ato gamiton. So using equation 1, we have a plus b equals negative 2. So, since we all know that RA is equal to 2, so ato substitute si A or substitute nato si A ng 2. So, nanata dire mag-start kini. So, 2 plus b equals negative 2. And then, b here, no, subtracting both sides by negative 2 para mawala si 2 dire. So, 2 minus 2, 0 na. So, ang mabilin is b. And then, we have there negative 2 minus 2, b is equal to negative 4. Okay, b is equal to negative 4. Hence, substituting the values a is equal to 2 and b is equal to negative 4 to a sub n equals a n plus b, we will have an equation a sub n equals. So again, si a nato is 2. So alista nato si a diri ng 2. And si b nato is equal to negative 4. So we have there 2n minus 4. Therefore, the general rule of the sequence is a sub n equals 2n minus 4. And this is the answer for number 3. Katong mga dili madala ng inspection, inganiun nato siya pag-solve. Now let's go to example number 4. Find the nth term of the sequence 3, 5, 9, 15, 23, and 33. So solution, observe that the nth term of the given sequence cannot be easily determined by inspection. Hence, we will solve this algebraically. The same with example number 3. So our first step will always be for us to make a table showing the value of n and a sub n. So we have there ang ato mga n nasa taas, ato mga a sub n sa ubos. So our first term is 3, second term is 5, third term is 9, fourth term is 15, fifth term is 23, sixth term is 33, and the nth term is unknown. Step 2, again, we will get the difference between each term of the sequence. And that is, first difference na to, 3 minus 5, that's 2, 9 minus 5, that's 4, 15 minus 9, that's 6, 23 minus 15, that's 8, 33 minus 23, that's 10. That's the first difference. So, if nga nagyapon siya, ato na sad kwaon ang ilang mga difference sa first difference for us to get their common difference. So, 4 minus 2, that's 2. 6 minus 4, that's 2. 8 minus 6, that's 2. 10 minus 8, that's 2. So, we have there, our common difference is 2. Since the first difference are not equal, we get the second differences. Observe that the second differences are equal in the constant which is 2. It means that the nth term of the sequence is quadratic in nature. Pag makakuha ta sa first difference palang daan, that means na atay linear ra. Pero, pag sa ikaduha na ta ng mga kuan, difference, that means quadratic in nature. Hence, we will use the quadratic equation. Ang sa to equation sa quadratic, that's a sub n equals an squared plus bn plus c to get its nth term. To do this, we have to solve for the values of a, b, and c. Thus, we need at least 3 equations to begin with. Okay? So, I think, kung kagaina, duha ka equations sa ito gigamit, karon tulo ka equations ang ato gamito. Note that in the table, when n is equal to 1, a sub n is equal to 3. Substituting these values to a sub n, an squared plus bn plus c, we get, sige. So, ang ato pang alistan dira is si n. Okay? Ato pang alistan si n. If ang ato n is equal to 1, then naatay a sub n na 3. So, a sub n nato, alista nato siya kini, alista nato siya ng 3. And then, si n dayon ato mga pangalistan. So, a times 1 squared plus b times 1 plus c. So, we get 3 is equal to 1 squared, that's 1 times a, that's a, plus b times 1, that's b plus c. So, this is our first equation. Again, tulo ka equation ng ato kwaon, so kutob ta sa ikatulo or sa third term, no? Substitute. Also, when n is equal to 2, a sub n is equal to 5. substituting these values, so a sub n equals an squared plus bn plus c. So again, kini siya, si a sub n, alista nato ng 5. So natay 5 diri, og si n diri, og si n diri, pang alista nato ng 2, kay n is equal to 2 man. So a squared, e 2 squared plus b times 2 plus c. So we have there 5, and then 2 squared, that's 2 times 2, 4 times a, that's 4a. B times 2, that's 2b plus c. So we have here our second equation, which is 5 is equal to 4a plus 2b plus c. Then, when n is equal to 3, and a sub n is equal to 9. So substituting these values to a sub n equals a sub n squared plus bn plus c. We get a sub n equals a sub n squared plus bn plus c. So, a sub n nato is equal to 9. So, butangan nato diri si 9. And then, n nato, pangalista nato siya ng 3. So, a, 3 squared plus b times 3 plus c. So, 3 squared, that's 3 times 3. 9 times a, that's 9a plus 3b plus c. So, we have here our third equation. Okay. So, using equations 1, 2, for our step 4, we will use equation 1, 2, and 3, no? We will solve for the values of a, b, and c by elimination or substitution method. So we have here equation 1, no? Kini ang ato equation 1, 2, and 3. So ato siya i-rewrite, no? So ingani na gibaliktad rin nato basig maglibog na sad mo ha. So a plus b plus c darira, and then c3 daira. So this is for our equation 1, equation 2 nato, og equation 3. Now first, we will use elimination method. So, we have here subtract equation 1 from equation 2 to eliminate the variable c. So, kinahanglan anay nato mag-eliminate sa variable c. Kaya kinahanglan na isa ka letters ang ato mabilin. Okay? So, we have here 4a plus 2b plus c equals 5 minus a plus b plus c equals 3. So, kinsa nga to? Si equation 1 from equation 2 ato silagi minus. So, we have there, no, since kay minus man, so mahimo ning plus, and then kada term, mahimo ning minus, minus, minus. We have here negative a, negative b, negative c, and negative 3. Then, we will add them for a minus a, that's 3a, 2b minus b, that's b, and then, makancel na ning si c minus c, that's 0, so di ra ka na to i-appeal, and then 5, plus the negative of 3. So, i-minus na to siya. That is positive 2. And this is our equation 4. 3a plus b is equal to 2. Okay, let's have letter B. Subtract na naman equation 2 from equation 3 to eliminate the variable c. So, again, eliminate gyapon na to ang variable c. So, i-minus na to si equation 2 from equation 3. So, we have there 9a plus 3b plus c equals 9. Minus 4a plus 2b plus c equals 5. So, 9a minus 4a, that's 5a. 3b minus 2b, that's 1b or b. Then, cancel na to si c. Okay? So, wala na si sa ubos. 9 minus 5 dajon, that's 4. So, this is our equation 5. 5a plus b equals 4. Okay, so we have now our equation 4 and equation 5. So, equation 4, equation 5, wala siya letter c, na no? Or wala siya variable c pala. Sorry for the word letter. That's variable c. So that means we can use that, no, kanang duha, to solve for a. And we will eliminate b. Sakto? So we have here 5a plus b equals 4 minus 3a plus b equals 2. So 5a minus 3a, that's 2a. b minus b, that's 0. So wala na, cancel na si b. And 4 minus 2, that's 2. Now, we can now solve for a. So, 2a is equal to 2. 2 divided by, dividing both sides by 2, para ang mabilin rakan is a. So, that is, a is equal to 1. So, ang ato a is equal to 1. Again, nanatay a is equal to 1. Now, since na naman tayo a is equal to 1, i-substitute nato si a, no, dito, or si 1 dito sa it's either equation 4 or equation 5. Depende na sa ato. So, siguro murag masadyon raman si equation 4. So, dito nato siya i-substitute. Pwede sad sa 5. Pwede sad sa 4. Depende ra sa ato. So, we substitute a is equal to 1, 2, 3a plus b equals 2. So, equation 4 niha. So, that is 3 times 1, that's 3, plus b equals 2. So, 3 plus b equals 2. B, so na-transfer si 3 sa pikas or subtracting both sides by negative 3 or 3, no? So, that means b is equal to 2 minus 3 and our b is equal to negative 1. So, again, nanatay a, nanatay b. So, ato a is equal to 1, ato b is equal to negative 1. So, pwede na ni nato siya i-substitute sa either equation 1, equation 2, or equation 3 ba. So, using the values of a is equal to 1 and b is equal to negative 1, we can now solve for the value of c by substituting them to either equations 1, 2, or 3. Same ra gihapon ang answer bisan asa nato sila i-substitute. Now, substituting this solve values to equation 1, we have the following solution. So, gamit na to ang equation 1 kay mas dali raman i-solve ang equation 1 compare sa equation 2 and 3. So, mas mupili ra gyud ta sa mga sayon-sayon ra para dili ta maglabad. So, we have here a plus b plus c equals. Okay, so we have here 3. So, si a nato again is 1, di ba? B nato is negative 1. And we will find for variable c equals 3. 1 plus negative 1, that's 0, plus c, that's equals 3. So, c is equal to 3. So, since ang ato a is equal to 1 man, and b nato is equal to negative 1, and c is equal to negative 3, then the nth term of the given sequence is given by a sub n equals an squared plus bn plus c. Okay? Therefore, ato ipang substitute si a, b, c sa kini na equation. Okay? So, ang ato a sub n is equal to, ang ato a is 1, ibutang nato diha, 1n squared. Ang ato b is negative 1, so negative 1n. C nato is 3. And then, this becomes a sub n equals n squared minus n kay negative 1 times n, that's negative n, plus 3. So, this is our general form na for this sequence. So, I think that's it. Do you have any questions? Okay, that's it. So, thank you guys for listening and God bless you all.